Good evening, everyone. Welcome to today's session on 3D printing and frugal manufacturing. Hi, Chetan. Over to you.
Welcome everyone. So yeah, so we will be going through the basics of 3D printing initially, and later on, uh, if you have any doubts, we can conduct a Q&A session. So we will be conducting a Q&A session in the last. Um, so yeah, let's begin.
So basics of 3D printing. I'll just introduce myself. My name is Bhavya Zaveri, and I have done my BTech in Mechanical Engineering from KJ Somaiya College, Mumbai. I'm currently working in Dassault Systems as a technical support engineer for 3D Experience SolidWorks. So whatever issues that people face or the industries face, they have they can directly contact us and we can get them resolved. And my area of expertise has been SolidWorks 3D printing. I've been printing various models from last 1 year and getting my skills and just brushing up on all the things that I can on 3D printing. So yeah, before we actually move on to what is 3D printing, we must actually understand why are we moving towards 3D printing. 3D printing is going to be one of the most fastest and one of the most growing industries in the coming 10 years. So why exactly 3D printing? So 3D printing is basically is nothing but a manufacturing process. Now for any manufacturing process, there are majorly four factors on which it depends. One is the material, the capital, the number of parts, and then is the object geometry. Now, for example, the material, you may have a metal, you may have a plastic. Accordingly, the machine has to be selected. Similarly, capital, obviously the cost is very important factor in anything that we do. Another is number of parts. If we are having a very high volume of parts, we will definitely have to incorporate robotic arms, or we'll have to incorporate automation in our manufacturing. And this is why it is very important to know why and what manufacturing we are going to use, and it depends on number of factors. And last one is the object geometry. More the complex part, the more advanced manufacturing systems are required. Here you can see this car. It would be very difficult to manufacture this car on, you may say, a CNC milling, or some other operation using some another manufacturing process. So these manufacturing processes are basically divided into three main categories. First is the subtractive manufacturing. What is subtractive manufacturing? Subtractive meaning removing material. So remove the very basic example is nothing but sculpting. You all must have seen sculptures, or how forts have been built in the olden times. It used to be a big piece of rock, and then the sculptor used to chisel out the material from that rock, and that is nothing but subtractive manufacturing. So in industry, we have a process called as CNC milling. So in CNC, we have a rod for here, as you can see in the image. We have a rod, and then the material is being cut out from that rod to desired dimension. So that is what subtractive manufacturing is. That is removing the materials. Next one is formative manufacturing. Formative manufacturing meaning you are going to have the material in the molten state. It is going to be poured into some mold, and then it is allowed to be cooled down. So that is how formative manufacturing processes are being built. So the very basic example is candle making. So candle making, there is wax, which is the material. It is in the molten form. Then it is poured into the vessel. It is allowed to cool down, and that is nothing. And finally, we get the candle. So the similar manufacturing example that we have in the industry is known as casting. Here you can see this is a hot molten metal which is being poured into the mold. So which is nothing but similar to candle making, but at an industry level. So this is known as the casting process. And one more we have is known as the plastic molding for plastic parts. And finally, additive manufacturing. Additive manufacturing means building layer by layer. A very basic example would be, you all must have seen these masons who build walls. So they are going to lay first a layer of bricks, then they are going to put some cement, then again another layer of bricks. So it is all going to be brick by brick, brick by brick. So it is a layer, and on it there would be another layer. So we are doing nothing but addition of material. That is what 3D printing is about. 3D printing is nothing but addition of layers to get the desired part. So 3D printing, why are we moving towards 3D printing? The major advantages are that it is very flexible. You can have your parts which are built immediately. You can just design them. You can give and slice the appropriate parameters, and then finally you can get your desired object within maybe a few hours. So this is one of the most important factors why 3D printing is important. Another example is that the sustainability aspect, I would say. The sustainability aspect, because there are materials in 3D printing which are biodegradable when are used at and when are treated under certain conditions, like PLA material. So to some extent, we can say yes, 3D printing is a sustainable process. So coming to the 3D printing now, till now we just understood why are we learning 3D printing. It is because of the complex manufacturing processes, the cost of the products, the number of products, and all of these parts have finally led us to the technology of 3D printing. Now, 3D printing is the very common form of 3D printing that we find here is fused deposition melting, which is a technical term, but in simpler terms, we all have used glue gun, right? So in glue gun, what is it? We just put the plastic filament, the glue gun is going to heat the filament, and from the other end, we are going to have a molten plastic. So that is what 3D printing is about. 3D printing is nothing but you are going to have a filament which is going to be inserted in the nozzle. The nozzle is going to heat the filament, and finally we are going to get the molten plastic. And these molten plastic is then going to be laid down layer by layer by layer, and finally we get the desired product. We can see the image here. It's just a time lapse of a small product of how it's being built layer by layer. So how do you actually 3D print? If you have certain object, how will you go about manufacturing it using 3D printer? So 3D printing involves three basic steps. The very first being 3D modeling, for which there are CAD softwares like XDesign and XShape. You all must have been familiar with XDesign and XShape till now. Next process is the slicing process. Slicing is nothing but converting the model into a language that the 3D printer will understand. So that is nothing but the slicing. And then last one is the 3D printer. So we are going to cover all the three processes and majorly the important aspects of these three processes so that we get the overview and we can start building on our products. So 3D modeling, you all must have seen the interface for XDesign. This is what XDesign is. Then we have XShape. Let's not go into detail since we will be talking about 3D printing more. This is XShape. So yes, there are certain things that have to be taken care while designing so that we get better 3D prints. The very first thing is checking your measurements. Oftentimes it happens that while designing, we put random dimensions. So here there is a random dimension. I have just put in 1 mm of diameter. So when I see on the computer, I am going to see 1 mm, which is so big. But in actual size, 1 mm is going to be even smaller than the hand which I've shown here. So 1 mm is a very small part and it would be very difficult to manufacture. So it is always recommended that in the initial stages, you at least have a ruler or you at least have some measure tape along with you so that while designing, you can actually take care that what part will you be, what dimension your part would be, how big your part would look. So all of these things. Next is the wall thickness. So in wall thickness is important because it is going to give the rigidity and strength to your object. So if you are going to have a wall thickness which is very thin, maybe 0.25 or 0.5, it would be very difficult to manufacture. And at the same time, it would be very difficult that this object is going to sustain your application. The very simple example I can think of is a phone cover. A phone cover would be having a lesser wall thickness because it has to be a bit flexible. It cannot be very hard and rigid. That is why it is a very basic example that we can relate to. Next is the clearances. Now, for example, I want to have an assembly, especially a moving assembly, and all the parts are to be 3D printed. Then what would happen? I have 8 mm, for example, I would have 8.5 mm of hole and I would have any object that is going to be sliding inside it, then I cannot have the diameter of the object as 8.5, because 8.5 and 8.5, it will never mate and it will never go inside it. So it will be difficult for us to handle such parts, and that is why it is necessary that you reduce the size of one part so that it would easily mate into the assembly and you would get the desired movement. And that is why this is known as the concept of clearance. You must usually keep 0.2 to 0.5 clearance in your 3D printing, depending upon the printer that you have. But yes, if you are having a hole of 8.5 mm, then it is suggested that you keep the part that is going to go inside it approximately at 8 mm. I hope this is clear to you. Then next is the slicing. So we have touched upon very few topics in the 3D CAD. Major focus would be on the slicing part. Now, what exactly slicing is about. So I'm just going to share my screen so that we get a hands-on demo of what slicing is exactly. So I'll just reshare my screen. Yes. So for slicing, currently I'm going to use Cura. Okay. So I already have a part. I have a simple part which is being built here, which I already built for demonstration purpose. So this is a part which I built using XDesign. The main aim I'm using XDesign as of now is to show that how to export the STL file. STL file is nothing but a file format that your slicing software is going to understand. Just like we convert the PDF from the Word format, it is very much similar to that. So this is a simple object that I built, nothing complex in this object. So what I'll do is I'll just export this model as an STL from here. I've already done that so that we don't miss out on valuable time. So I'm going to select STL and I'm just going to select export. After exporting, we would get something like, we would get an object basically. I'll just open the file here. Yes. So this is how the STL file will look. So I have currently imported it into Cura. So Cura is going to be our slicing software. Now, what exactly is a slicing software? A slicing software has two major functions. One is to convert it into G code. G code is nothing but the language that our 3D printer will understand. And another is the slicing software is going to slice our model into very small amount of layers, so that we get each layer as per, we get the properties of the layer and finally we get the desired product. So this is the object that we have brought in from the CAD, then STL, and then we have come into this 3D printing and into the slicing environment. So initially, when you bring in a product, it would be very random and you will have to place it appropriately. So let us say that I just align this face so that, yes, now I have a part which is aligned with the base plate. So yes, we can proceed further then. The very important parameters of slicing are layer height, infill, support, speed, and material. So we'll touch upon each of them so that we get a general idea of what these parameters are. So yes, the very first parameter is the layer height. What do you mean by layer height? Layer height is nothing but the height of each layer. In simple terms, we can have there are three basic standards. One is 0.2, 0.16, and super quality. Now, why is layer height important? It gives the surface finish. Now, when we are talking about surface finish, we are having a very good example here in this picture. This first one is having a layer height of about 1 mm. Yes. The second one is having a layer height of about 0.6, and the last one is having a very less layer height. You can see the surface finishes of each of these parts. The first part is having a very rough finish, and as a result, this part is also going to take a very less amount of time to print. So more finer you go, you get a much better quality, but with much better quality, you will require more printing time to print the same product, and as a result, more material will be there. So if this first print is going to have 100 layers, then this last print is going to have 200 layers for the same dimensions. So that is why layer height is important for surface finish. This is what layer height is about. And in the slicing software, it is available here. You can select the qualities as per your slicing software. Next is the infill. Now, what infill is, this material is going to have something inside it. Now, for example, I'll just slice this. Yes, so you can see here, this between the two walls of the part, there is some material in between. This inside material, the internal material, is nothing but the infill. The infill gives the product the strength and the rigidity that is important. And that is why infill is one of the most important parameters when you are slicing your product. There are a lot of infill patterns available. The most common being triangular, cubic, or grid. These are one of the fastest, and it is going to give your product the required strength that is required for at least our applications. There are number of other infill patterns. There is octave, there is gyroid, and these all are going to give you different strengths. So it is depending on completely on your application, what type of application and for what purpose you are building your product. And next is the infill density. The more denser your infill is, the more strength it will get, but at the same time, it will get much heavier. It will go and it will have a much higher print time. So it is required, it is an optimal that we can have around 10 to 30%. We can play around this range. Above 30%, it would get much harder. So this is where you can change. Yes, so just go to prepare. Yes, this is where your infill is. If I change my infill, it is going to be the material inside that is going to be much denser, and that means more material inside it, more strength. But at the same time, I require a greater amount of time to be printing it. So that is nothing but infill. The next part is the material. The material has basically two parameters. One is the printing temperature and one is the build plate temperature. Now, what are these? The materials usually require, as I said, it is a extrusion. It is the material is going to be heated and coming out from the nozzle, and that is why the material first has to be heated so that it comes out in the molten form. So the most widely used two materials, PLA and ABS. You also must be having these materials in your labs. PLA is having approximately it is to be heated around 190 to 210 degrees Celsius so that it comes out of the nozzle. And next is the bed temperature, or the build plate, or the bed on which your printing is going to be, or on which your part is going to be printed. So that temperature is important because that is the bed on which your layer is going to be stuck on, or that is important for the adhesion of the layers. That is why bed temperature is important. So these two parameters can be set here under the materials tab in the slicing software. So this is what material is about. The next would be printing speed. Yes, here is the printing speed. Now, what is printing speed? Printing speed is how fast your, in very simple term, how fast is your print going to print. So your nozzle, which is going to extrude the material, the speed of that while printing is nothing but the print speed. So usually the print speed has to be kept around 50 to 60, but you can play with the print speed also. You can go as low as 10 to as high as 120. The problem becomes that when you go higher, the layers will not stack on each other appropriately, and there would be something called as layer shifting. Now, this is a picture which demonstrates a good indication. We can have the print quality. You can see for 120 per second, it becomes, the quality is not much that we would like to have. Maybe we can have something between 30 to 60. So that is what our purpose would be. So we usually keep it around 50 to 60 and all these parameters are going to affect the quality of a product. So at the end, we just want to have good quality products. We want to have lesser print time, and that is why this is important. The next parameter would be support. Now, what support is? A very basic example for a support would be whenever we have a building which is being constructed, there are bamboos which are there in the building. Now, on completion of the building, these bamboos are then removed. That is a very simple example we can relate to. That whenever there would be a layer which is overhanging, or whenever there would be a layer on which there is nothing at the bottom, it would require some support. So we can see in the image here, this is the layer which is overhanging. If we do not give support to that layer, the layer would not be printing properly. You can see a T here. This layer here is not having any support below, and that is why it is not printed properly. So if we have supports below the T part, it is going to be have it will have a much better quality. And again, support is again going to have infill pattern and the density. We can see here, here there are supports which are much denser, which are much rigid in nature, and then we are having supports which are very less as compared to the previous one. So this would be easier because you can remove the supports very easily then. So at the end, we just have to remove the supports. It is just going to be there for building the part. And that is why it would be better that we keep the density very low for the supports. So next parameter that we have is the, I'll just check. Yes. Now I would just like to highlight one point here. Now, for example, I'm having this part here. We can see this blue part that has been built here. That is because when I just go up, see, there would be one layer here. There would be one layer here which would be requiring supports. For supporting this, the software has automatically calculated that it requires certain support, and that is why there is a support which is being built on the 3D printer. So what we can do is, to remove this, we can just simply reorient the product. For reorienting, you would just rotate the product. Yes, so let us see if we can slice this. If I have just reoriented my product, now we are having no supports. Just by reorientation of the product, we can have a better quality print. Not better quality, I would say, but we can save our some time, because in the previous orientation there were supports which are building, and supports building means your material is going to be wasted and your time is going to be wasted. So just by reorienting the part, now I would not have supports. I am going to have the same part at the end, but without any support. So I'm going to save on my material and my time. So I'm not wasting anything here. So this is why placement and movement of the part become very important. So this is one thing that you can always think of to avoid as many supports as you can. Finally, when I just press on save to disk, it would be nothing but a G code would be prepared at the back end. This G code is nothing but the language that the printer is going to understand. We need not go into details of G code because that is not for us, that is for the machine to understand. So this is how the G code basically looks like after final preparation of the code. 3D printer settings. Now coming to the 3D printer settings, till now we have seen the entire process, right from exporting the HTL file that we have created in XDesign, then importing the HTL file in the slicer, then we saw the different settings available in the slicer softwares, and now coming to the final 3D printing part. I have created a small video with the help of a 3D printer that is available at our 3D Experience Lab. Yes, I guess the printer is visible. So what is here in the printer is, the very first thing is that, yes. So the very first thing in the printer we want to have is the filament that is being heated. Here you can see the filament above on the printer. There is a filament here which is there, and in this filament, see, this is the filament that we are having. We can place this filament here. This filament has to be heated first. In order for this to be heated, we will have to connect it with the hot end and here is nothing but the nozzle. At the end, we are having this nozzle here is going to extrude the material, and this is the first thing for setting up a 3D printer. First thing that you need to have a filament, and you need to have a printer which is having the nozzle which is hot and preheating. The next thing would be bed leveling. So for bed leveling, we have got levels here. So what happens in bed leveling is that we can set the bed level. Now, why this leveling is important is because if we are not setting up the level properly, then either the layer would be not sticking properly, as you can see in the PPT. The layer would be the first layer would not be sticky, and due to which the problem would be the above layers on the 3D printer will not be printing properly. So that is why bed leveling is very important. And usually for bed leveling, what we do is layer would be the first layer would not be sticky, and due to which the problem would be the above layers on the 3D printer will not be printing properly. So that is why bed leveling is very important. And usually for bed leveling, what we do is we keep the size of we keep the distance between the bed and the nozzle in maximum to a size of a paper, not more, not less. So that is how we roughly do it. And the final would be bed cleaning. Here we have a bed which is not at all clean. We are having something from the prints previously. So this printer will definitely not give a better print. We will have these all prints, all the previous residues removed, and we can have a much better print then. And finally, printing of the first layer, as you can see in the slide. The very first layer that gets printed is very important. The first layer has to be perfectly stuck on the bed, and therefore the bed cleaning is also very important. This first layer that gets printed will ensure whether you have leveled your bed correctly and whether your bed is cleaned correctly. If the bed is not leveled, then as you can see in the image, the first layer will not get printed properly. If you see in the image that is on the slide, the bottom left corner image, uh, if the distance of the nozzle from the bed is too high, then there will be too much of spacing between the adjacent layers of your 3D print. If you see the nozzle is too close to the bed, eh, you will see that the filament is not getting deposited properly, and therefore your bed level has to be perfect. And also in order for your first layer to be stuck to the bed, your bed has to be cleaned, and therefore it is always advised that after each part that is being printed, you clean your bed. You make sure that the bed is cleaned properly. You can use IPA or isopropyl alcohol in order to clean your bed, but please be aware and use this under the guidance of your school teachers who are mentoring you, because if you use the wrong chemicals, it may cause damage to your printer. Thank you all for tuning in on this session on 3D printing. I hope we have been able to provide you with some valuable insights to get you started for your 3D printing. Thank you. Yes, so frugal manufacturing. What is frugal manufacturing? Uh, let's directly go to the community and just have a look what frugal manufacturing is. Frugal basically comes from a Hindi word which is known as jugad, or we can also call it as a hack. So the main aim of frugal in innovation, or we can say frugal manufacturing, is that to utilize the materials which are easily available, which are of low economic value, and you have to create a value which is much greater than it. And jugaad does not mean if you are not having something, you can easily, you just did some jugaad and just made your product work. But no, not like that. Having some impact or making your product a bit better. That is what frugal innovation is about. Bringing out or gathering what is very abundant and then making a useful innovation out of it. A very good example that is posted on this community is about Mitti Cool. So first of all, Open Frugal Innovation is a community which you all can join. you all can go through the ideas which have been posted on this community. There are very interesting ideas on this community. It is an initiative by the 3D Experience Lab at the Dassault Systems, and it is open to all. So you all, everybody can join this. I'll just share the link in the chat box. You all can go home and just look at this community. So coming back to Frugal, a very interesting innovation was known as Mitti Cool. Now, what is Mitti Cool? There was a person in the state of Gujarat where usually in summer season there is very high heat, I would say. So what happens is we all have used earthen pots for storing our drinking water, and we know that earthen pots are going to keep our water cool whenever there would be an increase in temperature outside. So in his village, there was a problem of energy, electricity, and it would be very difficult for the people around him to store basic items such as milk or curd. So for that purpose, it would be very important. It was a very thoughtful that it was very thoughtful of him to use his earthen pot skills and making a mitti cool or making a refrigerator. And this refrigerator does not use any electricity. It is just based on the principle of earthen pots. Earthen pots are used for storing our drinking water. Same principle he has made here, and he can store vegetables for now 4 or 5 days. He can store milk, curd for more than 24 hours. So this was an innovation. This was a simple innovation. It did not require any lakhs and crores of rupees, no complex R&D labs, nothing. Just a simple, thoughtful, resourceful, and he made out this, and he's now selling these products in more than 63 cities of India. So that is what Frugal is about. One more example. Now, staying at the Mythical, anyone would say that Frugal is something which would be very low cost, or something which would be very low tech, because y'all can see it is having nothing. It is not having any electricity or anything. But no, Frugal is also about high tech. Now we have one more example here known as Tiguna. Now Tiguna is a startup which is being supported by 3D Experience Lab. So in Tiguna, uh, the major problem that they identified was that we all have seen street vendors. These street vendors are carrying very heavy loads on their backs throughout the day. They are going to sit out in heat in the morning and go home in the evening. So it would be very difficult for them to sell their products. Keeping an eye out on this, Dassault Systems actually, the Tiguna actually came out with a solution to have a much ergonomic cycle and to make this cycle even electric. So this is a cycle which is used to reduce the loads of the workers. It is very ergonomic. Even women are able to use these cycles. They have kept in mind about different aspects of humans, and maybe it can serve all people of different social and economical background. So this is what Frugal is about. It is not just about creating something low tech, but you can also have an idea which is a high tech idea. So this is how they have used. You all can go through this post on the 3D Experience community of Open Frugal Innovation. So I have one more. I have one more model here to show you guys. It again is developed at the 3D Experience Lab. It is known as a multi-rotor power generation system. We have this setup here in the lab. I'll just change my camera and just show you guys this product. It's a simple product, but something that will be used and that can be used in majority of the places. And yes, it was supported by the lab. It was done by an intern currently working in the 3D Experience Lab. So I'll just show you that product, what that product is. We are having a pipe here through which the water is flowing. Inside it, there is a turbine, and this turbine, I have the model on the community. We'll just see it on the screen there. So this is how the system works. There is a turbine which is fit inside this pipe. So when the water flows, this turbine will rotate and generate electricity. This turbine is going to rotate. It is coupled with the shaft here of the generator, and here is the bulb which is going to glow. So entire setup has been made at the 3D Experience Lab. Everything is 3D printed. Even this coupler is 3D printed, and this motor definitely it's a bought out. It cannot be manufactured here. But this is how and what Frugal is about. You have to be resourceful in whatever you are trying to do, and yes, that is how you can go about making things more frugal way in your. Don't try to reinvent something. No, don't try to make the things more complex. Just keep it simple and be as resourceful, as thoughtful as you can, be more clever. Just find out the problem that you are having around and try to implement those problems. So that is what frugal manufacturing is about.
So that was a quick session on frugal innovation as well. So if you have any questions, you can post it in the Q&A box. So we have a question from Suyog, how to level bed. So different 3D printers have different sort of leveling, bed leveling attachments. But for every printer, the principle remains same. So there are four different screws which are attached to the at the bottom of the bed, and using a paper and like you can use various other materials to see where on which side of the bed the bed is on the upper hand or the bed is on the lower hand. Okay. So what is a jugaad? So it's a it's a like in frugal innovation, we don't actually build a project which is like according to the industrial standards, and we like try to build a project, and everyone who is engaged in the frugal innovation builds their project using whatever the resources is like available directly at their end, and no standards as such is follow, but they try to resolve the like immediate problem which is available in their society. So that is why we call it as a jugaad. So another question is from Upasni. What is the last date to submit X design? I'm not very sure about the last date. Sajana, do you have any idea of this?
No, this will be conveyed by their school champion soon.
Mhm. Okay, so better you connect with your school champions and ask them about the last date. From where can we download the software you have recommended rather than X design? So we haven't recommended any software rather than X design. So it was a software for slicing the 3D print, the STL model. So, so the very steps come from like building a model in the X design, then converting your model into STL through X design, and then using Cura to convert those STL file into a 3D printer readable model. So for that particular thing, you need a Cura software. Where can we download the software you recommended? Okay. Another question is from Gotham. As we have a public exam in March, like few days before. So another question is from Himanshu. How can we get Cura software? So Cura is an open source software which is like readily available if you just Google it out. I hope every the questions were answered. And if you have any question, you can just type in the chat box. Can we get link for the open frugal innovation? Yeah, sure. We will be sharing those links of open frugal innovation shortly with your school champions, and they will like forward it to you. How many rounds are there in total? Mm, Sajana, you have any like tentative rounds, number of rounds, or this will be conveyed like through the school champions?
Yeah, it is. It will be conveyed through school champion itself.
Sure, sure. I hope the platform link is provided to your school. And if not, you can just connect with your school champions and let them know so that they can provide you the uh, exactly where you can browse to the platform and start your design with X design. So another question is from Jaivik. Which infill is best strong? It really depends on the infill, but just remember that uh, the percentage of infill will consume more. The more the number of percentage of infill is, it will consume more amount of time. So based on the applied force on whatever the part or component of your assembly is, you just have to decide like to provide it with 100% infill, or if it works out, if it is just meant for the aesthetics purpose, you just need 25 approx percentage of infill. How hot should we make the printer? Okay, so generally we use ABS or PLA as a material for the 3D printers. So PLA generally requires around 220 degrees, and um, ABS requires around 180 to 200 degrees. So these temperatures are of nose temperature, the nozzle temperature, and the bed temperature remains 50 degree for both of the materials. Was a design which cannot be made in X design can be. So there are multiple roles in the platform. Like for the frames, you have X frame. Uh, for others, we have X design. For plastic purpose, you have X mold. So I would suggest that you connect with your school champions. You let them know what sort of design you want to make, and just be aware of what all softwares are capable enough to make your design, and just don't go for any other software. Everything will be fulfilled through the platform which is available at your end. Any Aarti, can you just elaborate more on your query? I meant which infill pattern. So you can go for any pattern like tree pattern, which is like generally used.
Okay, thank you everyone. Thank you, Chetan. We'll end this
Thank you.
session.
Sure. Thank you. Have a good day. Bye.